Welcome to my channel of Smart College. Today in this section of video I will go through the linear regression and analysis of variance. It is will be the number of videos, so it will be the introduction video about linear regressions and ANOVA. ANOVA full form is analysis of the variance. So it is the very important things for statistics and machine learning engineer as well as programmer. Those are good in machine learning and data science field. So first you should have to know about why we'll learn about linear regression and ANOVA. So if you build a model and if you want to perform anything on your model, so to make the model and how accurately your model giving the result, it is the most important things. So to do these things and to how you will build the model and how accurately it will give the predicted value of the given input, so this is the thing about we'll do in this section of video. So let's get started. First about linear regressions or linear model representations for your understanding purpose. So I'm in like this folder. I mean it is my working directory. You will set it properly where your working directory is there. After that it is my console, you know about, and data frame. And for understanding visualization purpose, I make the font size is now 24. I think it is good for you. So if any variables or functions is like y is represented in like this way, y is equal to beta 0, okay, or you can say b0. This is the thing. And after that plus b1 x plus another thing is added is called zeta. I'm giving here zeta is like this symbol zeta. So it is the form of linear regressions first. So y is called the values, that is the function about it will represent the functions, where beta 0 actually called the intercept value. Should have to remember, somewhere it is written as w0, somewhere it is beta 0, somewhere it is theta 0 written, but I'm written here beta 0 means intercept. You should have to remember these things. After that b1 is the coefficient value of input x. After that e, actually it is not e, it is zeta. Zeta is the error. So to know more about that, you can go through any of this video and explore each and every term. Now if it is for single values function, if there is a multi-valued functions, so it may be formed like this way. It will be x1, and after that it will be like b2 into x2. It will be like form of like this, or something else may be possible for multi-valued function. So let's get about started. Why it is so important? Okay, so why the statistical model is so important, you should have to know about it. Actually in the statistics model, each and everything about f statistics, each your if your f statistics is value is minimum, then you can consider your model is good. So very important thing is f statistics. This is the very important things you should have to consider. After that you should have to know about what is the coefficient significance. Actually coefficient significance is depend upon the two terms. One is t statistic, another one is p value. Actually probability values is the very important that you should have to understand from there. T statistic and probability value, it will become in the next few session of this video. T statistic, another one is p1 value. P means probability. Those are important things. After that, how you know that your model is important or not? To do these things, you should have to check to your model r square. R square is the value. It is sometimes called as the least mean square. So if your model is useful, then r square value should be minimum. You should have to check, or you should have to care about it. After that you should have to understand what the model fit well for the data. I mean, if you give the new data to the model, so how it will work. Do this thing, you will plot a residual plot. It is also very important. This plot is also important, residual plot, to understand the your model is working will be work on the perfectly or not on the given new data set, as well as you should have to do the regression diagnosis. You should have to do these things, and after that another things you should have to do, that the data is satisfied, is your linear regression properly or not. To do these things you should have to confirm, get the confirmation from this diagnosis of the model. So these are the questions, all these things are the very important. Now we'll move forward to the analysis of variance, and first we'll see how to make a model for simple linear regressions where only one data set is there and only one data frame. Data frame is nothing, the column of the data. Now in applied linear regressions, you maybe follow number of books is there, you can follow the video series as well as, if you follow my videos I think it will be helpful for you. So today for the introduction of this video up to here, if you have any questions please put it down the question in the comment section. Thank you.